Oh, I wonder what this lesson's about. Oh, using tables to graph functions. Let's get started. Okay, in the last lesson we were talking about functions. So just a quick review, this is read as f of n equals n plus 5. Now, in order to solve this, we need to create a function table. So here's our function table, here's our domain and our range and our rule that we just pulled from right here. Now, unlike the last section where you were given the domain, for this one you actually get to create your own domains to fill in. Now, what I like to do is always include 0 because 0 plus anything or 0 times anything is really easy. The other ones you pick is up to you. I like to throw in a negative and I like to throw in a positive, but it's not really a requirement. So here are the domains I selected, -1, 0, and 1. Filled in the domains for the rule. And those are the ranges for those domains. Now in order to graph it, I actually need to include a fourth column. All I'm going to do with this column though is take my domain, over here in this column, and my range in this column and put them together. So now I've created an ordered pair or an x and y coordinate to graph. This is my function table completely filled in. These are the 3 coordinates I need to graph on a coordinate plane. So here's our first ordered pair graph, -1, 4. Started from the origin here, went over 1 and then up 4. The second ordered pair graphed, and the third ordered pair graphed. The last thing to do is to connect the dots. Now the advantage of graphing this is you can see solutions that you did not put in your function table. So if you graph it properly, which it looks like I have a pretty good straight line there, I can actually take a look and see solutions for domain numbers that I didn't solve for. So for instance, 2, which is right here, the range would be 7. And then for -1 down here, the range would be 4. So not only do I have these 3 that I solved for, but I have all the solutions along this line for the numbers. This is called a linear function. Linear because what we did was create a straight line, so a line function or linear function. Now, not all functions that we graph are going to create lines or straight lines, so let's take a look at an example like that. Here we have f of n equals n squared minus 5. We'll first create our table. And for this particular problem, I chose to go with -2, 0, and 2 for my domains. For this particular problem, I wouldn't go with a number too large because you're going to be squaring it. So even if you go with a number, let's say like 4, you're going to square that and you're going to get 16. So then it's going to be a little more cumbersome to graph that on a coordinate grid. Here I filled in my information for the rule. Here's the solutions for the ranges. And here are my ordered pairs that I need to graph. There's the first ordered pair I graphed, the second ordered pair, and the third ordered pair. Now what you may have noticed already is this does not create a straight line. And the reason why it doesn't is because we squared the number. Now in order to put a line in, this is not going to create a straight line like I just said. So we just kind of have to do the best job of sketching it. For sketching the line, we're not really looking for perfection, we're just looking for something pretty darn close. So This is sufficient. It's not perfect. If I wanted a truly accurate answer, I would either use a computer or a graphing calculator to get a truly correct representation of how the graph should look. But for the level of math we're doing right now, this is sufficient. Of course, the disadvantage to this is we can't really tell what the other possible solutions are. But that is kind of the folly of a quadratic function when you're just graphing it on a piece of paper. If we wanted a more accurate representation, we would just include more domains, and therefore we get more ordered pairs to graph. But again, 3 should be sufficient for our purposes at this level. The last type of function was called a linear function because it created a straight line. This kind of function is called a quadratic function. Quadratic derives from the Latin word quadratus, which means square. So this is a function that we square. And if you look back to the problem, in fact, we do square the variable. So just a quick summation here. We have linear functions, and they're going to create straight lines. They can go this way or this way. This is called a positive relationship. We'll get to that a little bit later in the year. And this is a negative relationship. Or we could have a quadratic function which creates a parabola that can go up or it can go down depending on the equation itself.